Guys, in this video, we'll be discussing generators in Python. I am using IDE, PyCharm, and Python 3.12 version is installed on my machine. Before getting started with anything, let's discuss the problem first. I have very simple program which is producing even numbers up to the number which will be provided at the time of the calling, right? So the problem with this function is it will first prepare the numbers which are even, okay, and then it will return. Okay, if we run this program, so it will print all even numbers up to 100, right? If the number is very short, we can print it easily, we can get the output easily. But let's say if the number is very large, right, up to this number, if we want to get all even numbers, then we will have problem. Our programs will take lots of time to execute. It will not be memory efficient, right? If we run this program, so you could see a delay in the programs because it is first producing the result, then it is returning. We have to stop it because it is taking lots of times. And you see at the end, there would be a exception, keyboard interruption, or any other exceptions. In order to deal this type of situation, we have to use generators in Python. Okay, you can take another example. Let's say you have a very big file with you, right? CSV file with you. You want to read this file, okay, in Python program. Then again, it will take time. What if we create a function that does not produce all the item at once, rather it produces them one at a time and only when required. Okay, so we can control this type of behaviors. That solutions can be provided with help of generators only. First, we will try to create generators in Python with help of these magic methods. After that, we will see how we can use yield keywords. Okay, then we will see how to create generators object, how we can create generator expression, and then finally we will see how we can profiling the generator performance. Now let's start the video. Okay, now let me make this number small. Generators are basically function, as I mentioned, that returns traversable objects or item. These function do not produce all the item at once, rather they produce them at a time and only when required. Now let's see how to use next and iterator magic function. Will be producing a square of numbers with help of one class wherein we will be implementing next and iterator function. So let's create class first. Class say max equals to 0. So we'll be taking a number. We have to say max iter function self. Another function needs to implement, that is next. Stop iteration is a built-in. We have to then say result. Just give me the square of my number, okay, and return result. Right. So this is a simple implementation of itr and next function. Let's create a instance. C do square, we provide 5. Up to 5 we have to get all squares of these numbers. So we can then say next function. Okay, so this next function we have to pass on our object of 2 square, right? So what it will give us? It will give us the square of first number, right? If you print it, so the first number is 0. If you repeat the statement, it will give you the square of next number. If you repeat 2 times more, it will give you the square of next numbers always, right? 0, 1, 2, and 3. Okay, so you see with help of itr and next function how we are able to achieve generator in Python. So this is the control. In this example, you get the output when it is produced. First it produce the output, then only it will returns. But here we have more controls. Okay, because the function does not produce all the items at once up to 5 numbers. It is not giving us all the items, but it is actually producing item one by one at a time when it required. For next number, so you will get square for 4. 0, 1, 2, 3, and 4. Okay, it is maintaining the state, right? Next function is maintaining the state of the previous number. That is the advantage. Okay, If you want to use itr function, you can simply say, okay, you have to first initialize p, run the program. You see, again, the square of all numbers is produces up to 5. If you make it 6, you will get 6, 36, right? So now you are able to use next and itr function. Okay. Now you have created your own iterator with help of iteration and next function. If you want to achieve the same output here with the help of yield keyword, so what you will do? So why yield? Why yield? Because yield will eliminate the use of this itr next function. This is your own custom iterator, right? Yield will remove this dependency. Yield itself will maintain the state of previous item. Okay. So how we'll do? We have to just say instead of this result, we don't need it. Okay. Even we don't need it. We don't need this line. We don't need this line. We just need yield, right? And I. That's it. We don't need to return anything. Okay. If you produce the output, print next L1. So it will give you the first number. Okay. If you say you have to get another even number after this, you will get another, right? So after 4, we don't have any number. You make it 15, then you will get more. Okay. You see, this is the even number up to 6. If you print one more, you will get one more even number after 6. You get 8. One more, or even two more, then 8, then 10, right? 8, 10, and 12. So this way, with help of yield keywords, you have now eliminated the use of iteration, next, and init function. Even this case is also getting covered, right? In the yield keyword. Let's say if you put 3, so it will raise you exception because it will only generate the even numbers up to 3. After this, it will be terminated. It will be stopped, right? Because internally yield keyword is implemented the stop iteration. It is checking the condition also. Okay. So let's remove all things, right? We see now generator object. If you simply say you have your own custom logic so that you could create your own iterator, you can easily do with the help of generator function, right? So generator function could be anything. You can say f, you can say my generator, okay? And you can say anything, you can say yield 1, yield 2, right? Yield 3. Simple. This is your own generator. If you want to loop through this, so you can easily loop through as you loop through the list object, right? Very simple. In the program, you could see 1, 2, 3. You can take it this generator reference into any variables and use next. So it will give you the next element, right? 1. If you use it again, it will give you 2. Another, you will get 3. Now let's see what is Python generator expressions. So generator expression is similar to the comprehensions, list comprehensions. If you want to get a square of given numbers, you can easily do it, right? How? And this is called a generator expression. How you can loop through this generator expression? I in G. Similarly, you can print I. So you will get the square of the numbers. You see? Finally, let's see how we can profiling generator performance, right? Example of list comprehensions, and we will take the generator expressions and we will compare both how much size it will take. Okay. So first we have to import sys. Okay. And then we are going to get the square root of the number using first list comprehension. So multiply 2 square root, we are going to get 4 or maybe 500. Okay, and then we are going to get the size of, get size of this object, right? We will be, let's say, printing. Okay, we'll compare both, right? How much memory, you know both takes. This is list comprehensions, and we are going to now produce the same output with help of generator expression. So we have to say n, this is n2, and we are going to print the size of n2. Okay, let's run it. So you will see this is the size for list comprehensions, right, for n1, and this is the size for generator expression, okay, for n2. Now you are able to see how much memory efficient this generator expression is. Okay, it's a huge difference in terms of memory, right? This is the purpose why generators in Python introduced. You can get the benefit of this functionality. Okay, so these are all concepts in Python to create generators, right? We have seen next ITR magis function, we have seen yield keyword, we created generator object, generator expression, and then we checked how we can compare list comprehensions, and we can compare generator expressions. Okay, I hope found this tutorial very useful. If you have any questions, you can comment your query or concerns in the comment box, then we will cover up those queries, those concerns in our upcoming videos. Okay,
That brings us to the end of the today's video. We hope you found it informative and engaging. Don't forget to subscribe to our channel for more exciting content on all things tech related. Thanks for watching, and we will see you in the next video.